all started more than 30 years ago. Scarab actually was in a team with the Swedish state company trying to help out with the Chernobyl disaster. And afterwards we were invited to the Soviet embassy, and I got to meet Professor Borisov, who was the chairman of the Soviet Academy of Science. And he suggested that this technology that you're discussing, why can't we use it in space? And that was something entirely new for me. I never thought of it. And we met with ESA mainly and discussed the life support systems that were thought of in those days. I mean, there wasn't much life support on Sputnik. So I also got access to material from NASA, which was not published, but it was not confidential, but there were a lot of interesting things. The interest for deep space was more or less gone. And the Swedish Space Corporation chose to focus on satellites, and they were very successful, as you may know. I would say about 30 years later, I got a request from KTH, and the finding was that there still was not a good method for long-term missions. They looked at ISS. Sweden at that point had their own astronaut even. We checked ISS, and the conclusion was that the equipment available was not possible to use for long-term missions because it didn't recover the water well enough. Therefore, we started this project, HYDROMARS.
What we have in common is that we share the technology. We all use the same technology developed by Scarab a long time ago, and we are also improving every day. We are using two principal physical processes, the same processes that works in nature in the water cycle. It's evaporation and condensation. We heat water in a tank, and then this water is then pumped to a series of modules. Inside the modules there are cassettes. The cassettes are conformed by cold plates and hydrophobic membranes. And inside these cassettes only vapor can pass through the membranes, leaving behind all the pollutants and non-volatile compounds. That means that we offer a double blade solution for water purification, as we can produce pure water and also concentrate elements in one single step. Compare, for example, to other more common processes for water purification, like reverse osmosis, where they require approximately 80 bars. In that respect, our technology offers a lot of advantages compared to well-established or other water purification technologies. This simple technique has been applied in different academic studies, including removal of pharmaceuticals in collaboration with Teeh and AstraZeneca. We have collaborated also with Stockholm Exergi, cleaning flue gas. I will describe a little bit what's the flue gas and how we clean it. And we also collaborate with SLU in nutrient recovery, and also in other projects with desalination. We are also now working with the Indo-Swedish Rheumatology Foundation, where we have an installation in India removing fluoride and providing water for 200 students. We're also looking for application of biomaterials with rice, and also X0 is collaborating extensively with IMEC, this university in Belgium, where we are providing water for the last rinse in nanotechnology production. Additionally, we are working in another project with rice, where we are trying to concentrate nutrients as, with a view of a commercial fertilizer. Other important projects that they are thinking and coming in the future are, like Apo mentioned, deep space missions, also cargo ships, and concentration of valuable elements. So we have this industrial installation in Hammarby Höstadsverk, In this industrial installation, we have a very nice setting because we are using waste heat from heat district. So the heat that is provided to your houses needs to be produced usually by burning biomass. By burning biomass usually produce a lot of pollutants, and also we can clean the dirty water from the scrubbers. All the elements in the flue gas concentrate present in this contaminated water were below limit after we purify the water. So it's very efficient removing some nasty contaminants like, for example, mercurium, arsenic. Also, in the same setting, we also remove pharmaceutical residues from wastewater. So in the same context, we have a high concentration or some concentration in the wastewater, and after we purify the water, all these elements, all these compounds, all these pharmaceutical residues were below detection limit in our purified water. India has a severe problem with water distribution. All the rural communities need to extract water from the ground. And the groundwater is polluted with fluoride. Fluoride is naturally present due to the volcanic formation of India. We are collaborating with the Indo-Swedish Rheumatology Foundation, which contact us, and we have an installation in a northeast state of Odisha, in a school, where we provide water for 200 students. The water in the well has this high conductivity, and the water that we clean has this low value of conductivity. Conductivity is a good and fast measurement to indicate the ions in the water. So as the water is more pollutant, the conductivity is higher, 200 to 400 microsiemens. So we can tell that the water that we are producing in India for these school kids has lower conductivity than the water that we are drinking here in Stockholm. We are transforming the installation from diesel electricity production to solar power. So we are using solar cells to produce electricity and thermal collectors to heat the water in our process. We're landing here to the star of our company, which is X0, which is producing probably the purest water on Earth. It has passed strict tests on purity and nanoparticles, and now they are commercializing this reference water for labs and for nanotechnology production. Our technology has some advantages compared to other technologies present in the market. We offer a technology that is simpler, as we can remove pollutants and we can concentrate these pollutants and valuable elements in one single step, compared to other technologies that require many other steps for the purification. It's also consistent, always removes the contaminants. We can achieve zero discharge. We can recirculate the process, and we can extract all the water in the polluted water, like I say, concentrate the elements. It's also very efficient, as we can couple our technology with different industrial processes and different sources of energy, and is also economical because we need a lower capital and operation cost compared to, for example, reverse osmosis. But more important, our technology can be placed in industrial process with very confined spaces, and also it can be placed in regions where water is very scarce, such as in travels to deep space or probably in space stations.
A major challenge for the long-term space missions is the supply of water. And since refill of water is not possible on distant missions, complete regeneration is inescapable. On the other hand, such missions require detailed planning together with a worldwide collaboration because of the need of extremely high resources. And despite significant achievements in the space exploration industry, there are still significant gaps related to the inexistence of advanced closed life support system design. And as a result of cooperation with several research institutes and international cooperation, and following more than 30 years of experience working with water purification system on Earth, the concept of HYDROMARS has been developed. And the goal of the company is to commercialize a closed system for water purification in space with zero liquid discharge. It is calculated that one person, one astronaut, to go to the International Space missions needs 1 kilogram of food, 1 kilogram of oxygen, and 3 kilograms of water. And given that the return trip to Mars takes approximately 3 years, we can have a very simple calculation that it's needed at least 30 tons of resources to bring from Earth to the space. We also have to consider here bringing 1 liter of water and space cost $50,000. Increased efficiency of water regeneration is an absolute necessity for deep space voyages. And in 2016, the Swedish Department of Energy Technology at the Royal Institute of Technology performed a study on the existing system called Water Recovery System, or VRS. And the study conducted and concluded that although the system is fulfilling its role on orbit, but it doesn't allow and is not efficient enough for more longer space explorations to space. VRS processes human condensate, humidity, and urine, which constitutes maximum 20% of the total anticipated wastewater load, while more contaminated liquids like is water from dishwashing or water contaminated with chemicals or pharmaceuticals, they require more advanced solutions. And apart from that, the recovery rate, the highest recovery rate existing for now on VRS, is equal to 74%. Two problems we're facing: lack of efficiency and a very complicated system. And it's very logical to think that the solution could be either to find a solution of water regeneration technologies that can regenerate water at a more highest recovery rate, or we have to increase the capacity of the spacecraft so that it will be possible to lift this amount of the system. Now we are going to show you one original industrial large-scale equipment of Scarab. Here we also have one picture with a test at the Inter-University Microelectronics Center at IMEC, and which aimed confirming that technology is able to handle even the most difficult contaminants, and the outcome confirmed that purification capacity has generated strong interest within IMEC and other industrial associated partners. And here we have more modified, improved prototype. But going further, this is our latest result that more or less can be adapted to the spacecraft, and you can see compared to this person and compared to the systems that we already saw on VRS that it's at least 8-9 times less, it weighs at least 10 times less, and it's proved to be durable. So the next step for HYDROMARS for now is to test the system in the zero gravity condition. In 2018, after receiving Seal of Excellence from Horizon SME, we had an opportunity to sign an NDA with the biggest contributor to the space industry, Airbus Defence and Space. And the agreement is so that first we will build prototype according to their internal preferences and criteria. Then we will test the prototype in their lab, and there are 2 persons assigned for that, one from our side and another from the Airbus. And after that we will discuss some potential things for improvements. Our collaboration with ESA counts from 1988, and we are now also in partnership with them. We have recently submitted an application, and we were chosen among 10 best projects that have potential to contribute to the space industry. And our collaboration with the Royal Institute of Technology also counts a decade, resulted in 6 PhD studies, more than 10 master studies concerning Scarab's technology. Today we have highlighted this fancy lady, which is our expert in environmental communication, and will take care of contacting HYDROMARS with our main private partners. HYDROMARS will build a test unit for Airbus. This is our business model for Airbus, and after that commercial demos for Airbus, ESA and NASA. And we will use references from ESA BIC These are some of the achievements started from 2018. As I said, our Seal of Excellence from Horizon, it's our collaboration with Airbus. Recently, we were chosen from ESA BIC among 10 best projects that can contribute, as I said, and we were approached by the Cometa president, by his recommendations, by the managers of Creative Destruction Lab, and we went through the first process. We had an interview and we are waiting for the results within next 2 weeks. We need 6 months to reach Mars, and at average distance from Earth to Mars is 140 million miles. Apart from that, Mars is one of the closest habitable neighbor of Earth, and scientists said it's quite cold there, but it's possible to warm it up. Gravity on Mars is around 38% of what is on Earth. That means that we will be able to lift heavy things on it, and especially people who have problems with weight, they will weight less. And furthermore, the day is remarkably closer to the one that we have on Earth. It's approximately 25 hours. So HYDROMARS aims to contribute to make these travels possible. Thank you for your attention, and we're ready for the questions.
So my name is Nicolas Xafenias, and I'm working for RISE. I'm working at RISE Grants Office, and I'm also co-project leader for the project financed by Vinnova and Tillväxtverket that is called EU SME Support. So we support SMEs to find financing and succeed with financing from the EU.
Okay, if I'll continue, I'm Teeh Hedqvist, also with RISE, working with the metrology department. It's nothing to do with weather, it's more on the precise measurements, traceable measurements, and see whatever we can quantify, and the repeatability of the measurements.
Thank you.
Hello, good morning, everybody, and it was very nice presentation, especially for my background. If I'm mechanical engineer plus energy engineer on the sustainable issue.
Hi guys, my name is Ulf Andersson, and I'm divided my time between being a consultant for Swedish future scanning, focusing on water technologies and urban agriculture. And I'm also the chairman of the Swedish Space Society, the Swedish NGO for supporting space development. And if I may, Shorina, I have a question right now, or rather two questions. First, I would like to hear more about the energy efficiency of this process. I mean, it's basically vacuum distillation, and I see lots of possible applications both in space and of course also on Earth, in particular desalination. Another question is, your process is basically vacuum distillation. You produce very pure or ultra pure water, but in some cases human health, when you are thinking about drinking water, it could be not too beneficial to have too much pure water, because ordinary drinking water is at least tastes better if there are some minerals in the water. Not too much, of course, but I would like to have a comment on this question, please.
Yeah, we can come back to you with all the efficiency. That's a very important topic about drinking water and minerals. We have to work on that too. Yeah, of course, because especially in Mars, where probably the food will be limited on minerals, probably. Yeah, we will have to provide water with some minerals for the people drinking the water. And in general, yes, it's very pure water, and we have to probably spike the water with some minerals for drinking water.
Okay, thanks a lot.
Thank you.
When you are taking off from the Earth,
Yes.
I don't know how many G it is, 6, 8, something like that, and technical parts could broke during the acceleration.
That's true, absolutely. So the system has to be durable.
Yeah.
Yes.
Very, very interesting to hear. I didn't know a lot about your project before, but it seems amazingly cool. I really want to follow that. I'm really interested in what you're doing on the marketing side. We can take that later.
So yeah, thank you everyone.